Um, I'm sure all of you have heard probability in some form or another, whether it's someone speaks it or you've seen it in literature, print. Even the word chance implies probability. There's a chance of rain today, which doesn't seem like there is, but there's a chance of rain. That could lead you to believe one way or the other, like, well, should I take the umbrella or not? What chance are you talking about, weather person? There's a 50% chance of rain. Oh, well, I guess I'll take my umbrella. There's a 10% chance of rain. I don't think I'll take my umbrella. I think I'll just dodge, take my chances. And who's making that statement? Well, in terms of the weather people, they have forecasts and they've got things called Doppler radar, and they can do a pretty good job now comparatively to maybe even 10 years ago, where we trust what they have to say, even in a 5-day forecast, what to expect in 5 days. Or hurricanes. I'm hearing today that the Gulf is now, it's a tropical storm, but going to turn into a hurricane again. That's anybody who lives down in New Orleans or Mississippi, they deal with that all the time. Earthquakes. They haven't quite figured out yet predicting earthquakes. They're trying. There's forms of mathematics called chaos theory that they're trying to model when and how earthquakes have appeared, and to maybe do some predicting, like the stock market. Nobody seems to be able to predict the stock market. They just have historical evidence that might indicate if there's a bull, they call it bull and bear markets, when the economy shifts or not. And presidential election seems to affect, those every 4 years, the stock market one way or the other. Yeah, so weather is something. And so when you say chance, that's one idea. The horse racing. Sonoma County Fair used to have horse racing, and you'll hear the word odds. Oh, the odds. Odds are 2 to 1. That has something to do with probability. So for you guys, when you'll see here, you remember relative frequency? I think you'll shake your head. Relative. Remember I said that relative frequency is a fraction, decimal, and a percentage. Well, that's basically probability in a nutshell. And relative frequency can only go from 0 to 1 as a fraction, or from 0 to 100%. That's probability. So you've already had an introduction to it. Few other things. Experiments. Be something like an experiment. We're going to be dealing with today 3 types of experiments. One is a coin, the flipping of a coin. Another one is a rolling of a die, or 2 dice. And the third is cards. Now, some of you, you're going to be uncomfortable with cards because maybe 2 reasons. I call it a standard deck of cards. 2 reasons. Your culture, family dynamics, maybe even religion says you don't play with cards, you just don't do cards. However, for our math class, you have to be familiar with it. So in your packet, I've given you a printout. Your textbook has also of what a standard deck of cards look like. And if you want to buy a deck of cards, if you can, you might see that and lay them out and see how it's related to the pictures. So for our math class, you have to be familiar because I will be asking questions based on a standard deck of cards. I do not advocate gambling, not at all. Matter of fact, I should say I abhor. I totally, you don't do it. Don't do it. It's an addiction. Anything that's an addiction, you try to get that out of your system because it's going to cause a lot of problems. Could. The casino, I know people that go and play the casino just for entertainment. And they go with 20 bucks and that's it. And they have the willpower to step away and leave and then have their meal there at the casino and leave. Others get, and I've seen this before because I've gone into casinos with my, whatever, $20, $40, knowing that I'm going to leave it. I'm not counting on winning. I don't. Because in the casino, your probability of winning is low. It's very small. The best game where your probability of winning the best chances, doesn't mean that you will, it's still low, would be craps, the game of craps, which deals with 2 dice and a big table. Someone's throwing the dice, and then there's a stick person taking your money. Usually they take, rather than giving it to you, sometimes I've seen tables that people have racks of and they've made money. That's unusual. So I don't advocate the gambling, not at all. But we will look at games of chance and see how probability is connected, because it's definitely there with the casinos as a good example. So coins, dice, and cards, that's what the textbook tends to use. And then there's other illustrations of it too. So there'll be an experiment, and the experiment is flip a coin. That's the experiment. You take a quarter, a fair coin, not a 2-headed coin that you've heard people, say, it's not a fair coin. Yeah, heads and tails. And it's not weighted. Like I've heard of that, you feel a coin and gosh, it feels weird. So every time you flip a coin, it comes up tails, and you don't know that as the person who's betting, and the person who's flipping knows it. Or dice are loaded, sometimes loaded, so that means they're heavier on one side than the other. So we call it fair die and a fair coin. Let's see. So those are 3 experiments. Here's another experiment. I put everybody's name in a hat. And I'm thinking of the previous years where we didn't have this Zoom thing, where I actually took extra people in the class. 34 is the enrolled, but then I had 3 extra seats. So I had maybe 15 extra people hoping to crash the class. So I put everybody's name in a bag. I shook it up. This is a simple random experiment, and if you want to call it shake it up, everybody has an equal chance of having their name pulled out. So that would be 1 out of 15.
Okay.
Hi, Spencer. There you go. Shake it up, and I pull out a name. Hey, 1 out of 15 chances. That's your relative frequency. You have 1 out of 15, which is the probability. Now, to draw the next name, because I've already set aside that person, they're in, the 14 people have 1 out of 14 chances to get the next spot. So the actual probability increases, the chances increases. And then finally, you got 1 more spot. And so anyway, that's a form of probability, to look at the percentage you have. Okay, here's the capital S. Remember I said little s, which I made or the machine made, whoever made it, doesn't matter, I'm correcting it. I think I told you, didn't I send you guys
Yeah.
an email? I think it might have been last night, saying that there's a problem number 32, I think it was. And it turned out that should have been false rather than a true. It was all about a symbol. So I made the corrections last night, I believe, to your class already, and bumped up everybody's grade to 3. And if it wasn't your class, then it'll be I did it to the other class accidentally. I tried to pick your class because this morning we were having class. Anyway, that number 32 will bump everybody's grades up by 3. I elected, I think there was 1 or 2 that picked it as true and the machine graded it as correct, which in theory, that's not correct. I think it was, gosh, I don't know if it was X bar. It was X bar or S on number 32. And that's sample mean, and that's sample standard deviation. So somehow 32 was one of those symbols. And if you picked true and it came out to be 3 extra points, I decided not to penalize you. You got a free extra 3 points. But in theory, I should have taken 3 points away. I think there was 2 people that I should have reduced your test score by 3, because really you have to know that this is sample mean, and 2 people didn't realize it. Sample mean, and the vast majority, all of you said, whichever one it was, you said the right answer. It's false. You knew what you're doing, but it came out that the machine graded it wrong. So, and this is sample standard deviation. So this all the sample stuff. This big S, not the little s, this little s is in your calculator, but it looks like a capital S, but it's sample standard deviation. The big S for you guys, and it's in your symbol packet list, it's called sample space. So on occasion, as you saw on the test, sometimes I throw in a symbol or 2 or definition to see if you're actually reading and knowing your symbol and vocabulary. Excuse me. There's something called the event, and it's a subset of the whole sample space. And so I have to kind of tell you what the sample space is about today. So might as well just go down here for a moment. If I look at, the experiment is tossing a coin. Okay, so you either got heads or tails. So if I listed with little curly cues in mathematics, that's usually considered to be a set notation, set. So it's like a collection of things that are happening. So here's a collection of all the outcomes. See, these are called outcomes. Outcomes would be, you can get a head, that's an outcome. On a flip, you can get a tail, that's an outcome. So collection, all of those outcomes, heads, tails, is called the sample space, and we end up putting little curly cues to kind of indicate that collection. If you roll a die, a fair die, there's 6 sides, and so the outcomes would be listed right here. You can get a 1, a 2, a 3, or 4, or 5, or 6. Those are your outcomes. The collection of all of them is called the sample space. Now, if I said event, event right here is a subset. Now, subset means it's part of all of this. So it's usually not all of it. What if I said odd numbers? Odd numbers. See if anybody's waiting in my weight room here. Give me a second here. I'll see if anybody's in my weight room. Nobody. Okay. Odd numbers. Now, event then would be this. Here's your event. 1, 3, and 5. So that's part of all of it. So that's called an event. And if I said, hey, what's the probability of E? Probability, what's the probability of E? Well, what's E? Those 3 things, or odd numbers. What's the probability of getting an odd number? You'd say, well, how many odd numbers are there? 1, there's 2, there's 3 odd numbers out of all of them. So 3 out of 6, not that number 6, but since there's 6 numbers. So the sample space tells you how many outcomes, I get total outcomes there could be 1, 2, 3, 4, 5, 6. The event is part of that. So it's like relative frequency, how many you have at the top out of the total. So that this is always in the denominator of your probability. So if I said, what's the probability? You'd say there's 3 outcomes that are odd out of the entire sample space. So the probability is 1/2, or say 50%.
Hey, Jeff, would you rather we do fractions or percentage?
Or decimal, you have a choice. Fraction, percent,
Yeah.
decimal, there's a choice. Just like relative frequency, there was a choice. So I don't care. Spencer, on the test, your answer will be one of those 3. So you just got to know how to convert percentages into decimal or vice versa. Okay, a few rules for probability. This just says, second rule, says that the answer is between 0 and 1, inclusive. So the decimals or fractions can be as low as 0, nothing. The probability of rain today is 0%, 0% chance. That's the weather forecast. Okay, it could be 0. Can't be negative. Probabilities can't be negative. That's dumb. Can't be more than 1. Or, here's a figure of speech. I hear sports athletes always say this. Gave it 110%. I gave it 200%. That is impossible mathematically. You can't do that. 100% is everything. You can't say 150%. That's stupid. But anyway, mathematically it's stupid. Figure of speech, I get what they're saying. Give it the extra effort, This means, you guys know what that symbol means. You're adding a bunch of stuff. So if you add up all the probabilities, like the column for the relative frequency, remember doing that? If you add up that column for the relative frequency, it's got to be 1 every time. It has to equal 1 every time, or 100%. And that statement, which is a symbol in your packet, P of E is a symbol in your packet. One of the, I think I got 41 symbols. So you need to, and that's the formal definition right there for that symbol. Word for word. 1, 2, 3, 4 words. Spelled exactly that way. If I gave you it on a baby quiz, my expectation is you know how to spell, and you spell it exactly the way it is. Capitalize doesn't matter. I should put those answers in for your baby quiz. But it's word for word. You just don't say probability. You don't say probability event. Probability of an event. That's the formal definition. And to remind you, back here in the back of the packet is, if I did it all right, there it is, number 12. And here it is, number 12. It's there. Okay. And the classical method, N, capital N. Now, okay, a little confusing. E is event and capital S is sample space, but this capital N with that means the number of. It doesn't mean population size, I guess. Plain old capital N by itself is population size. So this means the number that you'd find in the event divided by the number you'd find in the sample space. You just count, basically. So to do these, like this one here, you'd say, okay, sample space, capital S equals, and you got head and tail. That's where the 2 comes into play, because there's 2 of them. And if you flip a coin once, you either get a head or a tail. So you're looking at the probability of heads, that's the outcomes. So you just count, hey, there's 1 head out of 2, 1 out of 2. sample space for the die. So you got a 1, a 2, and a 3, and a 4, and a 5, and a 6, and close that up. All of that is your denominator. So there's your 6. And if I say even numbers, then you go, how many even numbers are there? Oh, there's 3 right there. There's 3. And I would say get in a habit of reducing fractions. On your homework, I won't look in that detail. I won't look for that detail on your homework. I'm just looking to see if you attempted your homework, and I give you your 20 points, all the sections. But on the test, they're going to go for the lowest number. They're going to go for reduced answers. So even though these are the same, that's what's going to be choice-wise. You won't see both choices there. I'm not going to try to confuse you that way. You'll either see this, or you'll see the 50%, or you'll see the 0.5 for that, but you won't see 3/6. So you got to get familiar to reduce again. Okay, now the deck of cards. Now, standard deck of cards, I don't know if I've got my, oh yeah, I do. Sometimes I, so. Now these aren't in any order. I don't think so. Nope, they're not in order. But there's 4 different, what they call them suits. I'll just take these guys out here. There's 4 different suits. That's called a club right here. That's a club. 4-leaf clover, we call it a club. And that's what you'd expect. That's called a heart. And this is what you'd expect. That's called a diamond. That's called a spade. So you can see half of them are red and half of them are black. That's true. And there's 13 cards in each one of these. So each one of these suits get 13 cards, and that's called a face card. That's a face card too. That's a king. That's a jack. These are face cards. That means since there's 4 different suits, each one of them has a king. So there's 4 kings, 4 of everything. So, if I do the math, that means there's 13 cards, and I'll explain where the 13 comes from. 13 times 4 suits, that's 52. There's 52 cards altogether in a standard deck. 52 cards. The thing called an A, that's called an ace. Ace. What are other special things here? I think that's really it. There's a queen. See, there's what's called a king, queen, jack. Those are called the face cards. Those are the only face cards that you have. So if there's 3 face cards for every suit, there's 4 suits. 4 times 3 is 12. Oh, there's 12 face cards. So if I said, hey, what's the probability if I shuffle these up and had you draw randomly, let's say draw 1 card, like that one, what's the probability, what's the chance, what's the likelihood of getting a face card? You'd say, well, how many face cards are there in here? There's 12. How come 12? Well, there's a jack, queen, king in each suit. There's 4 suits. So 3 times 4 is 12. There's 12 face cards. Okay, I have 12 chances of getting one of those out of 52 cards. So 12 out of 52. And whatever that reduces down to would be your answer. Now, if you think about, okay, if there's 12 face cards, there are, how many non-face cards are there? It's called the complement. Complement. So the complement of rain, it's going to rain outside today. What do you think the complement of rain is? Anybody? What's the opposite of rain? That's another idea too. Sunshine. Okay, how about not rain? That means the same thing. What's the complement of rain? Not rain. What's the complement of getting a face card? Don't get a face card. Well, how many non-face cards are there? Well, a couple different ways of doing it. I can start counting all the non-face cards. Well, there's one, there's two, oh, there's three, there's four. Okay, that's a hard way of doing it. I could subtract all the face cards from the total. That means you subtract 12 cards from 52. I did that right. Yeah. And it gives me 40. There's 40 cards that aren't face cards. So the probability of not getting a face card would be, what, 40 out of 52. So I have more chance of losing. Let's say I want to make a bet. Let's say I say, Giselle, you want to play a game? She says, yeah, I want to play a game. Says, all right, Giselle, it's going to cost you $1 to play the game. What? I don't want to play. You said don't gamble. Says, no, but listen to what I have to offer. You give me $1 and then I'm going to let you pick one of these cards. Now, if you get a face card, I'm going to give you $10. Oh, yeah, I still don't gamble. Okay, I'll make this even better. If you give me $1, you pay me $1 to play, and you get a face card, I'll give you $1,000. Now, are you interested in playing? She goes, oh, yeah, it's only $1. Yeah, it's only $1. Sure. Yeah, okay. So she gives me $1. Let's say this is her dollar right here. Okay, gives me $1. Now, that's me. That's in my pocket. Now she's hoping to pull out a face card. Now, if you do, Giselle, and it's $1,000, and I give you $1,000, you really only have earned $999 because your original dollar is sitting over there. So you really only won W-O-N-E, no, it says spell it right, W-O-N, won $999, not $1,000. Keep that in mind later on. So she says, okay, I say, which one does she pick? She says, that one right there, that's my favorite. Okay, yeah, okay, fine. And we flip it over. Remember, the probability of her winning is 12 out of 52. Okay, so we go and if she doesn't get a face card, that's okay. She only lost $1. But she's got quite a few face cards. So let's see if she wins $1,000. No. And then you'd say, okay, well, I lost $1. And I say, Giselle, do you want to play again? $1,000. Wow, that sounds pretty good. Yeah, what's $2? Okay. Yeah, I can find some change in my car, underneath my seat, crack of the seats or whatever. Yeah, okay, finds it again. And so I mixed them all up. And here's another $1. Okay, so she gives me your other $1. Now I got $2 from her. Now she gets the $1,000. She's now only won $998 because remember she gave me. So which one? Oh, the first one right there. It's got to be one. Yeah, flip it over. Nah, sorry, another loser. I'm not saying you're a loser. I'm just saying. Shoot. Okay, one more. Because now this is where you're thinking, even at the casino, man, that slot machine's going to win. It's going to hit big. I just feel it. I want to win my money back instead of walking away. Okay. Okay, she's going to play one more time. So here's her other $1, purple right here. Here's another $1. So now she's paid $3, hoping for 1,000. Hoping for 1,000. Okay, Giselle, where do you want to go? High or low? You can go up or down.
Hi.
Hi, how you doing? Oh, wrong. Hi. Okay. Somewhere up here? Higher?
Yeah, right there.
Okay, right there. Okay. Okay, I'm rooting for you. I'm rooting for you. Sorry. And you're saying, hold it. I bet you there's no face cards in there. You wonder that. I wonder if it's rigged. Oh, look at that. Threw the Joker in. You actually had 54 cards. Oh, no, there's face cards in there. See, there's other face cards in there. Yeah. So it's not rigged. I just won $3. She lost $3. She stops. Done. So, yeah, probability with the cards, you're going to have to know that there's 52 cards here. How many hearts are there? Well, let's see. There's hearts, clubs. There's 13 cards in each suit. So 13 out of 52. Okay, let's say Giselle. Hey, Giselle, you want to play this again? Sure. You got another dollar? Sure. Here's her yellow dollar right here. Okay, throw it in. Okay, what are you playing for? Well, I think I'm going to keep this down to maybe 10 bucks. Okay, you pay $1 because there's a lot of hearts in there. She has a 25% chance of winning, 13 out of 52. Because there's 13 hearts out of 52. She has a 25, that reduces down to a quarter. Oh, okay, so, all right. Tell me when to stop, Giselle.
Stop.
Okay, I'm rooting for you. You want a heart. That's what we're hoping for. Okay, now you've lost $4. Do you want to continue to play?
No.
Oh, so she steps away and says, okay, I'm good. Okay. Smart. I'm going to teach you guys, if not today, I'm going to teach you in chapter, I think it's chapter 6, about when you think you should stop, or even if you should play. I'm going to teach you when you should play the game or not. When is it to your advantage versus the other person's advantage? It's called expectation. And should you even play the game or not? Because maybe we shouldn't even play the game and she would have not gone to the casino. Because if you think about this thing called expectation, you should not even go to the casino because you'll expect to lose. So that's what I'm saying. People will go to the casino and just say, I'm just there to get a drink, there to get some dinner, and I've got $50 just to sit and play. Maybe I'll win, maybe I won't. But if I lose the $50, who cares? I was there just for an hour's worth of entertainment. That's the attitude to go into the casinos, my opinion. Okay, so we'll go over here. Now, it's not the greatest image, but this whole thing is called the sample space. So if I go over here and go curly Q, now it's kind of light, but you're rolling 2 dice. This is like what they call craps at the casino. So C-R, can't even spell it. C-R-A, awful word. I don't know why whoever came up with that word. Even
We
say
clearly didn't give a crap.
Well, they call it you're crapping out too. When you when you get craps. By the way, craps is if you get a sum of a 7, or sometimes even 11. Those two, but in particular 7. If you get a 7, you just crapped out, because usually most people don't bet that the dice is going to come up a 7. And speaking of dice, my examples of dice here. Oh yeah, I got one. Come on, I gotta have another one here. Are you kidding me? I usually have 2 dice. All right, well, I only got 1 for today. Okay. But if I had 2, let's say I have a red and a blue, that really distinguishes them. But on the casino table, you can't tell the difference. I mean, they're the same color dice. So I even think I got this from the casino. Look at that. Oh yeah, the Horizon Casino, when it used to be called the Horizon. Now it's called the Lake Tahoe. It's called the Hard Rock Cafe, Hard Rock Casino. That took over what's called the Horizon. So you can see that Horizon. Anyway, they were, you can buy these in it used to be called vending machines when they decided not to use these. Anyway, if I look at my chart, this could be, the first column is red and this one's blue. That helps, so this would be red and this is a blue. So red 1 and a blue 5 is different than a red 5 and a blue 1. Different, even though they're not red and blue, they're the same color. For probability's sake, you got to count them differently. So there's 36 outcomes altogether. Red, blue, red, blue, red, blue, red, blue, red, blue, red, blue. Okay. So craps, when they say you just crapped out, is when the sum is a 7, because that's when they play craps, you're always looking at sums. 7, okay, like this. Okay, how many ways can I get a 7? Well, I just count out my 1, 2, 3, 4, 5, 6. There's 6 ways to get a 7. 6 ways to get a 7. So the probability of sum equals a 7 would be there's 6 ways out of 36. That means 1 out of 6. That means, in theory, if you rolled the dice, I should have a second dice. I'm going to, hold on a second. Why do I say hold on? You're not going anywhere. I'm looking in my bag of tricks. I gotta have some of this. Hello, come on. All right. Well, had I have a second die? Oh, I can do it this way. Watch this. I can do this. I can just roll this twice. I can do this. So I'll just roll it twice. And what I'm going to do is I'm going to roll this twice, but 6 times. It says that I would expect that when I roll 2 dice 6 times, one of those should be a 7. A sum should be a 7. So, okay, watch this. Okay, there's a 1 plus a 6. There you go. Okay, record a 7. Okay, now, okay, I record a 7. All right, now try it again. I got to roll it 6 times. Okay, there's a 1. And a 1 is a 2. Okay, 2. Sum is a 2. But I've already got my 1, 6. There's a 1. And a 3 is a 4. Okay, 1 plus 3 is 4. There's a 2. And a 3 is a 5. We got 2 more. Okay, there's a 6. Plus a 6 is a 12. And 1 more. Okay, there's a 6. And a 3 is a 9. Okay, so I have 1, 2, 3, 4, 5, 6 rolls. And one of them was a 7. Hey, there it is. That's what I would expect. What I expect. Now, they create that crap game in such a way that the payouts, it's always favoring the casino. It's always favoring the casino. On occasions, you hear somebody go, woo, because they hit it big, because it does come up. Like, okay, how many ways can you get a 12 out of here?
One.
And there it is. Now, they would have something on the board that says, hey, if you get a 12, we're going to pay you big bucks. We'll pay $1,000 or something like that. We'll pay $1,000. You go, whoa, okay, sure, I'll put all my money on that. Well, but you have 35 different possibilities that it won't come up a 12. That's why they're giving you a big payout to see if you'll bet that way. There's 1 out of 36. You would think that if you played 36 times, you're going to get a 12. You'd think. It doesn't always happen that way, but you'd think if you play it long enough. But that's why they're going to end up saying 7 is the most frequently occurring. See that, 7? The sum. Everything else is less than that. What about 10, Jeff? Yeah, well, there's only 3 10s. So when you guys do the math on this, and that's what you're doing right now, what's the probability that the sum is a 5? Well, it's all out of 36. So the probability that the sum is a 5, you'd say it's out of 36. Well, where's my 5s? Well, there's 1, there's 2, there's 3, there's 4. Okay, it looks like it's 4 out of 36. And that reduces to what, 1 out of 9? That means if I rolled it 9 times, I should get one of them to be a sum of a 5. I should. Or if I rolled it 36 times, I should get 4 of those being 5s. Should. Okay, sum to be odd. So let's see, probability sum is odd. So this is called the event. So it's out of 36. And all you do is if you can list out the sample space, so this is capital S is equal to all of this. All of this whole thing would be called the sample space. So I'm looking at odd numbers, sums. Okay, well, you're not going to do 1 and 1 is 2. So you're just going to look, well, aren't there just as many odds as there are evens? Kind of makes sense. It's either odd or even, yeah. I would think out of what 30, I would think 18 of them are odd. And you can count them, you'll find out that's true, so. Oh, Jeff, what does this mean? Well, it means if I rolled it twice, one of them should be odd, the other one should be even. Okay, sum, let's try this, sum. Okay, there's a 3 plus 4 is 7. Okay, well, that's an odd. Let's do it again. Oop, you didn't see that, okay. Okay, 6 plus 3 is 9. Hey, there's 2 odds, isn't there? O for odd, even. That means they're both. Does that mean to you that it'll be odd every single time? That means, let's say we did it 4 times. There should be 2 odds and 2 evens. Right now, if I did this, there's 2 odds. Okay, let's do it again. Let's see if it evens out. Okay, there's a 6 plus a 4 is 10. Oh, there's an even. There's a 2 plus a 3 is 5. Oh, okay, well, that's 3 out of 4 is, there's a 5 plus a 6 is 11. Okay, looks like it's heavily weighted on the odds. There's a 2 plus a 6 is an 8. But if I keep doing this for, let's say, 1,000,000 times, it'll be pretty darn close. The 500,000 would be odds and 500,000 would be even. It's called the law of large numbers. The law of large numbers. Okay, so this would be your answer for that one. How about this one? Look at that phrase. Remember that phrase, less than? So it'd be like this, probability that sum is less than. You guys need to know that that does not include the equal sign. The less than does not. 5. Okay, now it's out of 36. And what you're going to do is you're going to count all the numbers that are less than 5, sums. Well, let's see, is 4 less? Yeah, 4 is less than 5. Okay, so 4. Okay, so there's 1, 2, 3 numbers that are 4. Oh, less than 5, here's less than 5. And here's less than 5. All the circled are less than 5, not equal to 5, but less than 5. 1, 2, 3, 4, 5, 6. So all you do is count. That's the way I'm teaching you. If you list out the sample space, that'll be the hard part sometimes, is every outcome. Can you list out the outcome? So on the test, if I said this, oh my gosh, well, guess what? You've got open notes, open book, don't you? So you just find the picture in your book of the dice and then just count for the answers. Same with the cards. Same with the cards. If I ask you a question about cards, just look at the nice picture in your textbook and then just count how many queens there are. What's the probability of getting a queen? Well, let's count how many queens there are out of 52. This is what, 1/6? Okay, sum of 7 or a 5. Now, here is a word or, and. Okay, or means that you include both of those scenarios, and means it has to work for both, has to be the same that time, both. Let's do this one first. I want the probability that you draw, you roll 2 dice, and the sum, when you add up the numbers, is a 7 and also a 5 at the same time. Impossible. That's impossible. You can't get a sum of a 7 and a 5 at the same time. So this probability would be 0, the number 0. Whereas over here, okay, you start off with the 7s and the or, then you go to the 5s. So these are all out of 36, So how many 7s did we have originally here in this diagonal? Yeah, there's 6 of them. Oh yeah, okay, there's 6. Or 5s, how many 5s did we have? Okay, so it's right here where all the check marks are actually. 1, 2, 3, 4. Looks like there was 4 5s. So add those together, common denominator is 36. So you just add these as 10 over 36, and then you reduce that. Okay, probability, it's a prime number. Prime numbers, oh, shoot. Okay, anybody remember what a prime number is?
Can't be reduced any lower.
Give me an example of a prime number and see if what you're
1,
thinking.
3,
Okay, 1.
5.
Okay, I'm going to stop. 1 is not a prime number by definition.
Oh, that's right.
Okay, keep going. 3, I would agree with 3 and 5. Okay, what's the next prime number, Spencer?
7.
Okay, keep going.
9.
Okay, 9 is not a prime number. You know why?
No, you're right.
Well, but why is 9 not a prime number?
Wait, no, actually, I don't know why.
Okay, anybody know why 9 is not a prime number? Yeah, Natalie?
Because you can't divide it by anything but 1.
Okay, you're close to
Yeah.
the definition. You're closer to the definition. Anybody want to take a stab, or maybe even Natalie? What's the definition of a prime number?
I'm still wanting to go with like it's indivisible by anything but 1 and 0.
Oh, not 0.
But not 0. Wait, yeah. Okay, never mind. Sorry.
Okay, no, but so you're getting there.
One and
Number
itself.
that can be, there you go. Someone else just jumped in. 1 in itself. A prime number is a number that's only divisible by 1 in itself. That's
9
what-
would therefore not qualify.
That's right, because it's divisible by 3 as well. So that's not prime. It's called a composite number. If it's not prime, it's called composite. So yeah, prime numbers. Okay, here's a prime number. Okay, and by definition, we throw out the number 1. That's not. So what's the first prime number then if 1 doesn't count? Well, someone said 3. Okay, is there anything lower than 3 that could be a prime number, or that is?
No.
Well, actually there is.
Does 2 count?
2.
It does count. Yes, 2 does count.
2. Okay.
Because by definition, it's only divisible by 1 in itself. Well, yeah, no other number goes into 2 other than 1 in itself. So it turns out 2 is the lowest. 2 is the only even prime number as well. Only one. The rest of them are all going to be odd. But when you get to, say, 9 is an odd, you skip it because something else goes into 9 besides 1 and 9. The next one is 11. The next one's 13. How about 15?
No, but 17.
Right, 17, 19. How about 21?
No.
Right. How about 23?
Yeah.
So you get the idea that they're going to be odd numbers, and some of the odd numbers are composite. And so now what you're doing for this problem is not all of these are in the dice, right? You can't get a sum to be a 17. You can't even get a sum to be a 13. So don't count those guys. So these guys are what for this problem, you want to see. Add up all the numbers, or how many scenarios, that you can get a 2, a 3, a 5, a 7, 11. All right, so here's what we can do. I'll highlight it here. Okay, there's a 2, sum to be a 3, and then a 5. Oh, shoot, I just screwed that one up. That's a 4. Sorry, I said all the highlighters. Okay, I'm going to do red now. Sorry about the highlighter. Okay, that's 2. That's 3, not 4. This is 5. These are all prime. The reds are prime. No even numbers other than 2. 7, yeah, that's prime. Sum of 7, that's a prime number. No 8, no 9. See, the next prime number has got to be, what do I say down here, 11? Yeah, no 9, no 10, but 11. So all the red marks are the prime numbers. Okay, so I'll count them. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. All right, so it appears that it's 15 out of 36. 15 out of 36. That would be the probability that the sum of your prime number. Okay. Cards. Cards. I listed right here all, and it's not a great image. If you're doing your textbook, there's a color copy in your textbook. That might be helpful if you flip there in your textbook right now. Everything's out of 52. So all the fractions, it's out of 52, out of 52, out of 52, out of 52. Okay, drawing a 10. All you do is count how many 10s there are, not a sum, and just how many 10s. Okay, well, let's see. There's 1, 2, 3, 4. 4 10s. And I'm not going to reduce. You guys should know how to do that. I'll just say you want to reduce. Probability of drawing a 10 or a face card. Okay, now the or means you're going to include both of them. So how many 10s do we have? We have 4 of those. So we have 4 10s. How many face cards do we have? Face cards. Oh, these are all face cards. So I think there's 12 all over here. 4, 6. Yeah. So plus, what did I say, 12? So 16 out of 52. And of course, reduce. Okay, probability that it's a spade. Okay, now spades are these guys right here. Those are spades. There's 13 of those. Okay, next one, probability that it's got to be a spade and a red card at the same time. You're pulling a card out. Can you get a spade that's a red card? Is that possible?
Yes.
Okay, show me up here where there's a
Oh, I'm sorry.
No.
Red card is not a spade. Yeah.
right. The red cards are only diamonds and hearts, so that's impossible. This one's going to be a 0. Okay, this one here, number 5, says, I want it to be a spade. I want the card to be a spade and at the same time a face card. Are there any spades that are face cards?
Three.
Yeah, and there are 3. Very good. Here's your spades and there's your face cards. Okay, so there's, you just count them. There's only 3 face cards that are spades, so 3. Now, there's a difference between the and the or. Okay, I want a spade or I want a face card. I want a spade. So I know there's 13. I'll write it up here. There's 13 spades right there. How many face cards are there up here?
12.
Well, It look right. I heard the but. That's good. But what?
You've already counted 3.
Right. So you can't double dip.
Mhm.
So Jan's going to say, well, I'll count all the other face cards because the spades included the face cards. So you either add those up, which is 25, and then subtract the extra 3 that you counted, or you just count your spades up, which are 13. Don't count those again. Just count the extras that are right here. So there's 9 plus 3, or 13. 9 plus 13 should be 22. It should be 22. Or if you add these up, that's 25, and then subtract the 3 that were the spade, and that'll still give you 22. Okay, with the probability it's an ace or a jack, ace or jack. Okay, they have nothing in common. By the way, when they don't have anything in common, there are some phrases that we might use. They're mutually exclusive. They have nothing in common. That's called mutually exclusive. Or the other phrase is they're disjoint, mutually exclusive, disjoint. They have nothing in common. Okay, so how many aces? There's 4. How many jacks? There's 4. So it sounds like there's ace. There's 4 aces. There's 4 jacks. There's no way a card can be an ace and a jack at the same time. Can't do it. And again, reduce. I don't think that can be reduced. And that's just 0. And this can be reduced. Of course, that's a 4th, and so on. When you can reduce, I suggest you practicing that because your test is going to have reduced answers. Okay, and I think this might be the last. Yeah, this is the last section. It's an introduction of what's called tree diagrams. And you'll be asked to develop some of those on your group quiz, your homework. And I think I might ask you on the test, I might be able to find a question or two that asks you questions from a tree diagram. not to create it, but if I give you one, could you answer questions from the tree diagram? So the one I'm going to show you here is with 2 kids. It'll feel like 2 dice. Okay, so kids and dice are similar. A dice has 2. I said dice, my mistake, I apologize. A coin. Kids, two coins, 2 kids. If you look at a coin, you either have a head or a tail. If you look at a kid, it's either boy or girl. So same idea. So if you did this with coins, this could be head, tail, head, tail, head, tail. 2 children, what's the chances if you didn't have any fertility drugs or you're messing around with nature, things like that, if you just said, I'd like to see what the probability would be without any knowledge of my family history, genetics, and things like that, that could come into play, background of having both girls, because I just want both girls and I like paying for a wedding. I want to spend money on a wedding. Traditionally, that's what happens in the United States. Well, maybe things have changed nowadays, but way back when, I've had friends that had 5 girls, and I said, oh my gosh, it's going to break the bank, because usually the parents of the girl pay for the wedding. So that's the only reason why I kind of chuckle at that. It might be different nowadays that everybody splits the cost, or they just elope. I don't know if that's a word that's used anymore. Just going to run off to Las Vegas and do our own thing. So what's the probability of getting both girls? Well, all you do is count how many outcomes. This is called the sample space, and I'll show you how to do this. This is called the sample space, big S. Well, there's 4 outcomes in the sample space, and there's only one possible arrangement that you get both girls. So both girls right here, right down here in the bottom, that would be 1 out of 4. There's only a 25% chance that you're going to get both girls. Exactly one girl. Oh, I'm just counting here. See, if I go here, this is your firstborn, and this is your secondborn. Your firstborn, you either get a boy or a girl in your firstborn. Then the secondborn, you can either get a boy or a girl. So if your firstborn is a boy, then your next one can be a boy or girl. If your firstborn is a girl, then you can either get a boy or a girl. You follow along the branches of the tree to get your outcome. So girl, girl here, okay, girl, boy here, and so on. So it's a way of organizing your work. And then I can just count. So probability getting exactly one girl. Doesn't matter about birth order, just one girl. Okay, there's one girl, there's one girl. Oh, that's 2 out of 4. I just counted how many one girls I have. Ooh, at least. Okay, does that include one? When I say at least one girl, does it include one, like equal? I want at least one girl. Does there have to be a girl? Yes, there does. Okay, at least. Now, if some of you are saying, I'm not sure about the word at least because I'm still thinking on that, you go over here to your phrase, at least. Okay, here it is. Oh, I got it circled right there. At least is, oh yeah, it has the equal sign. See, right over here, it includes the equal sign. That's the answer. So you have to have one girl, 2 girls. You can't have 3 girls with 2 kids. So one girl or all girls. So one girl, all girls. Okay, that would be 3 out of 4. And then one girl, one boy. Now, I'm not saying, this is not implying that the girl is first and the boy is second because it's written this way. It's just a girl and a boy. So that would be these 2 guys right here. A girl and a boy. There's 2 of those out of 4. And then, of course, reduce some of them. The last page I'm not going to do. It's just simulation. I've done this a little bit with rolling the dice a couple times, and you saw, how that works. I'm not going to do that. And the only other thing that I want to show you is I was literature again. I read a book on this astronaut, and very interesting. Like Oprah Winfrey gives thumbs up on book clubs. I give a thumb up on this. This was good. It was a good read. Interesting. You don't have to be a math person or a science person at all. It's just interesting on his life and what he did. He was part of the space shuttles and the Hubble telescope, repairing that. So it was very interesting. Anyway, part of his book, I did an excerpt right here, is because he was writing here. Okay, launching 2 shuttles would expose the 2 crews to fatal conditions. You'd have to read, like, what do they mean fatal? Like something's not going to happen. It came down to probability. Okay, there you go. What are the odds? Again, odds has something to do with probability of taking a hit. A hit was a space debris that was out there, and he's doing a spacewalk to do repair. What's the probability of taking a direct hit of space debris on him when he's repairing it? What are the odds of that hit being catastrophic and not repairable, not just on him, but on the actual Hubble itself? Now, what are the odds of that happening 2 times in a row? Okay, we're not going to go with the probability on that because it's a little more complicated, but there's a way of determining that and whether or not it was worth the risk to go out. That's what they're kind of determining. Is it worth the risk to go out? Once we did the math, the probability got pretty low, like very, very, but it wasn't 0, but it was small enough for them to live with, meaning they're going to take a chance, go out, and probably come back safe. So I just put that in there because sometimes you see it in literature, and now you see the word probability after today. And hopefully it makes some sense with just cards, dice, and the coins. That's all you're doing for me. Okay, so with that, you've only got one section, 5.1. That's all. Today was kind of an easy day. Is there any general questions? And then what I will do is stick around for anybody that has specific things they want to go over with me, like on the exam. Dasha, maybe one thing you and I might chat because there are emails. I'm just thinking of Dasha. If there's anything that's the lecture related, and Spencer, I see you there too. Maybe we should chat too. But anything about the probability that I just went over? Okay, I will be back here at I think it's 2:30 to 3:30 at my Zoom. Does anybody need the Zoom link? Because it's been a while. Because I'll go find it and put it in the chat before you leave. Anybody need the Zoom link? Looking around, looking around. No. Okay, so if that's it, that's all I've got for you. Stick around if you have personal questions about anything. I'll be happy to address that. Otherwise, see you on Wednesday.
Thank you.
You're welcome. Okay, some questions here. Dasha, I can't remember if something that's just private you and I should chat about afterwards. And if that's so, then hang in there. If you're okay about talking about what our email back and forth was, I can start with you.
Would you prefer that we do it now or tomorrow for the appointment at 1?
You and I, oh, that's right. I did say, let's see, tomorrow's Tuesday. I did pose that to you, didn't I?
Yes.
Yeah. We can do that tomorrow at 1, and it'll be a Zoom invite.
Okay.
And then I'm going to write myself a note right now before you leave so I can set that session up. And I'll send it to you sometime this afternoon, and then I'll see you at 1 tomorrow. So let me write this down. Dasha Zoom Tuesday. Yeah, I'm thinking of my schedule on Tuesday. I have this break between 1 and 3, so I can do it tomorrow.
Okay. Thank you.
So 1 o'clock, we decided. Is that right?
Yes.
Okay. See you then.
Okay. Thank you.
Spencer, I know that we've had a few corresponding emails. Is it something that we can talk right now with other people here? Would you rather not? And then I'll leave you for last.
It doesn't really matter for me. I'm just more, I don't know how long it will take. I'm just concerned about the homework on the exam for the last exam. I know I sent it all in. I can send you an email of it if that's at this point easier. And I checked this morning on the Canvas app. I'm able to pull up each and every single one of the homework pages. There should be 18. And you said that you could I finally found your comment on it.
Oh, I
I was
think yours
panicking
was,
earlier.
I think yours, that's right. Yours had every page. Now I clicked on a majority of them, so I didn't do every page, but yours, it was the same section, that if I'm remembering right. So let me bring it up again, Spencer,
Okay.
and I'll let you know again. I'm skimming through my, yeah, okay. I'll even show you what I'm also seeing as soon as I get it up.
Okay.
Well, maybe yours wasn't. Maybe it was somebody else's. Let me see what okay, 3.5.
Well, it said I got a 3 out of 20, and I was like, but I did all the homework and scanned it all in on
Okay.
time.
Oh yeah, okay. So I'm gonna, yeah, this is what I'm seeing. So let me share my screen, show you what I'm seeing.
I should bring it up on my computer, not my phone. See if that makes a difference.
Can you see my screen now?
Yes, I can see it.
Okay, the one I clicked on, it looks
Yeah,
like
I see that.
this one that I'm pointing to, number 25, because it's underlined. Now I'm just going to randomly pick like 20. See, and it says 3.4 up there. I'm going to randomly pick 20. Same one. Now I'll randomly pick
What the heck?
16, number 16. So I think that's what I did is I did 2 or 3 of these. Whoa, this is the same thing. And that's why I sent, yep, same one. So
That is weird.
if you can send me them again, and why don't you, since you can't send it through Canvas right now, send it to my
Okay.
jclark@santarosa.edu and send
Yeah, I have your
me.
email.
Yeah, and then I'll take a look at it. I'll respond back later on today when I look at it, and then change
Okay.
your score. And then change your score. That's the reason why I only did whatever 3 points, because I only see one section. So go ahead and do that, and I'll change your score as soon as I see it all.
Okay. Yeah, I'm just really quickly while you're on here trying to view. Mine won't even show. Sorry.
So while you're doing that, Spencer, I'm going to see what
Okay. Yeah.
hang in there if you want to, no problem. Natalie, what would you like to talk about?
Yeah, is it okay to ask a question on like the exam now
Yeah.
at this point?
Yes.
Okay. So I'm sure that I kind of understand maybe like why I got this wrong, because I'm looking back over the book and I see maybe how I messed up. But it was on question 5 talking about the biographical information on the 5 most recent presidents, and it's just listing which variables are qualitative. I put A, president, state of birth, and religion, when I realized it should have been B, state of birth and religion probably.
Okay.
But the reason I put A is because it lists president, and I was wondering if that is technically qualitative or if that's just a category.
Okay, let me bring my test up while I was listening to your question. I'm going to see if I can bring this up. Look at the question, open the PDF. And remember which problem that one was?
Number 5.
Okay. So when I'm looking at the chart, here I'll show you what I'm also looking at. Share my screen. I think it's that one. So what I'm looking, let's see, qualitative. Okay, so I'm looking at words, not numbers.
Yeah.
So let's say state of birth and religion. State of birth and religion. State of birth, religion. Now, you said A?
Yeah, I had B originally, and then I changed my answer because I thought maybe the president would also count as a qualitative.
Oh, it would probably. I don't have any. See, there's nothing here that might have said presidents might have been here. For some reason, I might have taken them out. So why I left president in there, that's interesting. So which answer did you pick?
I put A.
I would say that would be okay. I think the answer here would be B, based on what you see. President, I see how that might trip you up because there's no word president, but gosh, that's a name.
Yeah, because
So-
our book, it talks about, like, I'm looking over in 1.2, it talks about qualitative variables,
Absolutely.
and it doesn't list the very first one as a qualitative variable. It just lists it as a category.
No, I'm just going to say yes on that one for you. Not a big deal.
Okay.
And let me find you here and I'll make the change immediately. Let's see if I can find your. Oh my gosh. Hey, Natalie. You know what's going to happen here, don't you?
Yeah.
Yeah. Congratulations. Perfect test score. Good job.
I'm having fun in this class. I've never liked a math course before.
I am very happy for you. That's a perfect 100%er. Okay, I just changed it. I think it's done. Tell me if you see it on your end.
I will check.
Okay, and if not, I'll go back and do something different here. Let's see. SP. Oh, I see it as 100 now, but you see if yours got changed to 100.
Yeah, let me see. Yep. Okay, that's all good.
Okay,
Thank you very much.
you're welcome. Jackson. Questions? Nice looking horse, by the way. My wife would be very impressed, and she loves horses. I don't know if you're there. She rode horses for kind of a living for a while. Jackson's not there. Okay, stepped away. Spencer, we're back to you now. Neither one's there. I'm going to go to lunch if you guys aren't still there yet. So I'll give it 60 more seconds. Give you one more minute. Jackson Spencer. Jackson Spencer. Yeah, you guys there? Jackson or Spencer?
Hey, so I went and grabbed
Over.
my phone real quick.
Okay.
Yeah. And on the, yeah, because on the computer, I actually saw what you saw. But when I'm on my Canvas app, I'm able to pull up all of them. So I'm not really sure why that is.
Okay, so for today, let's have you just go ahead and send it to my J Clark, and I'll respond back. If I see the same thing, I'll say, hey, I'm still seeing all. You'll have to try
I'll do that.
different. And if you want to do it right now while I'm kind of here,
Yeah, if you don't mind, I'll
no,
just
I don't mind
try
at
and-
all. I'm just going to look at some emails here while you're doing that.
Oh, okay. Fudge. All right. Let me try this. Reason why you see 3, 4 only is because that I when I took the pics, so I scanned it from my phone because it wasn't scanning a PDF format through
Yes.
my grandmother's scanner on her
Okay.
printer. It would only
Okay.
go to a picture.
Okay.
And so, and I don't think that's acceptable on Canvas. So, yeah, I did them backwards. So I went 3, 4 all the way up to 1, 2. So that's why you're seeing 3, 4 first. But as I realized, I tried to do each individual one on my like files app, and then what it's doing is I didn't realize it's it's all of them for all 16. So I have 16 copies of the same exact thing. So I'm gonna try to send this PDF,
Yes. Okay.
but I don't think it's gonna work because it says still 7.8 megabytes. So J Clark, let me just try it. Not Clack.
Yeah.
All right, so let me send that. Okay, so I sent that off. Let me try, and this won't be late, will it?
No.
Late. Oh, okay, good.
No.
Just wanted to make sure. You know what? I'm gonna look at it through this as well. See if I can open it. Somehow it's bigger. It's 10 megabytes. So if I download this. Okay, yeah, on my phone through the email app, I'm able to view it and it scrolls like this. You can't really see it too well, but
Yeah, I see that now. I'm looking on my email since you sent it. I'm looking. It has yet to come through yet.
I'm actually going to check it on my computer as well to make sure that this works.
Oh, okay. It just came through.
Oh, I also on Canvas, if you scroll down, you see all of them.
I'll try it again.
Yeah,
I'm seeing them all here. Let me try the canvas again. Maybe I didn't do the same thing. That would have been silly to me because I do scroll down.
I'm literally just with two on my mouse rolling down and it's scrolling.
I usually do scroll down on everything, but I'm going to do it one more time. Maybe that caught maybe that threw me off. I saw all these pages and I click. Oh, they're all the same. But I think you might be right. And I'm going to scroll down until we'll get way down at the end. 1.2. Yeah, I see it. So that's what it was. I see 2.1 now. I see 2.2 and 3.1. See, 3.2 should be, no, 3.3 should be 3.4 would be the next one. And then finally, that's it. See it. Okay, my mistake for not having scrolled down.
No, that's okay. I apologize. I didn't know that either.
But I had 15 different PDFs. That's what threw me. It was, whoa, my gosh. And I didn't realize that they're all the same one and just scrolling down. So
I didn't either. So I'm in the wrong as well here. I messed up. I submitted multiple different ones and they all are the same thing.
Well, we both learned. So this
yeah, I did.
This is
That's easier though for me and for you.
I'm going to
Okay.
before you leave to make sure you see it, that I'm changing the score to the 20.
Okay.
And,
Okay, thank you. I'm sure I knew there was something that must have gone wrong.
Okay,
But,
check it right now before you leave, if you would. I just clicked on